Solving systems of equations by substitution, this time when they are not in slope-intercept form. So let's take a look at these steps, which are basically the same as what you've done. The only difference now is, so like the other day, you had to make sure the equations are in slope-intercept form. But now if they are not, which you will see today, you must rewrite the equations into the proper form. You'll then set the equations equal to each other, solve the equation for x. Then once you get the value for x, you will substitute that x value into one of the two equations that you have in slope-intercept form to solve for y. Once you have the y value, you will put together your x and y values into the ordered pair x, y to make the solution for the systems of equations. So let's take a look at some of these examples. First example, we have these two equations, y equals negative 3x and 4x minus 2y equals negative 20. Well, one of the equations is in slope-intercept form, and as it says here in step 1, you must rewrite if it's not in slope-intercept form. So the second equation, we're going to have to rewrite that first. So that's what I did here. 4x minus 2y equals negative 20. I'm going to have to get that y by itself. So since I want the y by itself, I'm going to have to move the 4x by canceling it out with a negative 4x. What I do to one side, I will do the same to the other side. That will leave me with negative 2y equals negative 4x minus 20. I still need that y by itself. So if I want that y by itself, I'm going to have to divide every term by negative 2. So when I divide each term by negative 2, that leaves me now with y equals 2x plus 10. Now the equation is in slope-intercept form. I have this equation and this equation now in slope-intercept form, which means I can now set the equations equal to each other. So negative 3x equals 2x plus 10. I'm going to follow my steps for solving equations with variables on both sides by moving the x term of 2x to the left by subtracting 2x on each side. And when I do that, these two x's will cancel out, leaving me with negative 3x minus 2x is negative 5x equals 10. And divide each side by negative 5, and x will equal negative 2. So now I have my x value of negative 2. I'm going to rewrite one of the original equations and substitute the x value of negative 2 into the equation. So y equals negative 3x. I decide to take the shorter one. Y equals negative 3. Substitute the x with negative 2, and you get y equals 6. Now I have my x value, my y value. I'm going to put them together and get a solution of negative 2, 6. Moving on to my next example, I am first going to look at my equations and see if they're both in slope-intercept form. Well, one of them is, the other one is not, so I'm going to have to take this equation of 3y equals negative 9x minus 12 and rewrite it into slope-intercept form. Well, since I want the y by itself, I'm going to cancel out that 3 by dividing both sides by 3. That will cancel those out. Divide each by 3, and y will equal negative 3x minus 4. So now I have this equation in slope-intercept form. This equation was already in slope-intercept form. I'm going to take those two equations and set them equal to each other. 5x minus 2 equals negative 3x minus 4. Using my steps to solve equations with variables on both sides, I'm going to move the negative 3x by adding 3x, canceling those out. That will then give me 5x plus 3x makes 8x minus 2 equals negative 4. I'm going to add 2 to both sides of the equation, cancel those out, leaving me with 8x equals negative 2. Divide both sides by 8, cancel those out. Now I have x equals negative 0.25. Take one of my equations, so I'm going to rewrite one of the y equals equations. So either this one or the one where I rewrote it already here. I took the y equals 5x minus 2. Since that was already given to me, I didn't want to take a risk of using the one that I rewrote in slope-intercept form in case I made a mistake. So y equals 5x minus 2. I substitute the value of x, which is negative 0.25. So 5 times negative 0.25 gave me negative 1.25 minus 2 gave me y value of negative 3.25. So now I have my x value, my y value, put those together to make my ordered pair. So the ordered pair is negative 0.25 and negative 3.25. That's the solution to this systems of equations. Okay, so now on this last one, I am going to work this one out. First thing I need to do, look at my equations, and I notice neither of the equations are in slope-intercept form. So I'm going to have to rewrite both of them. So I'll take one equation at a time. Negative 5x plus y equals negative 2. I need the y by itself, so I'm going to cancel out this negative 5x and move it to the right side by adding 5x here. Cancel those out, adding 5x here. Now I have y by itself equals, now because the negative 2 and the 5x are not like terms, I can actually combine them together. So I just write them side by side, putting the x term first, minus 2. So y equals 5x minus 2 is my one equation. Now I'm going to rewrite the next equation. So then I have negative 18x plus 6y equals negative 12. So I want the y by itself. Here's my y. Oh, that made it hard to see. Let's go. All right, so we want the y by itself. So I'm going to move the negative 18 first because the 6 is directly with the y, so the negative 18x needs to be canceled out first. So I will add 18x here, cancel those out. I will add 18x here. Leaves me with 6y on the left equals, now remember I can't combine the negative 12 and the 18x because they are not like terms. So I just write 18x minus 12. Now from here I still need my y by itself. Here's my y, but it is being multiplied with the 6. So I'm going to need to divide each term by 6. So y is equal to 18 divided by 6 is 3, and put the x back on. Negative 12 divided by 6 is negative 2. So now I have my two equations in slope-intercept form. Now that that part is done, I'm going to need to take my two equations and set them equal to each other. So I have 5x minus 2 equals 3x minus 2. So I'm only taking this part since they're both equal to y and setting them equal to each other. All right, so I will follow my steps for equations with variables on both sides, which is move the 3x to the left, subtracting 3x, and subtracting 3x here as well. 5x minus 3x is 2x minus 2 equals negative 2. Add 2. Now remember, if you don't remember these steps, refer to your notes in your digital notebook on variables, equations with variables on both sides. That leaves me with 2x equals 0. Continuing on, It's okay that you have a 0 there. 0 divided by 2, x will equal 0. So now I have an x value of 0. As the steps say earlier in the notes, take that x value with one of the equations, and now you could use one of the original equations, but since we rewrote the equations so they are in slope-intercept form, I might as well take one of the new written equations. So I will take the, let's see, the y equals 5x minus 2. It doesn't matter which one you use. And I'm going to substitute that x value of 0 into my equation. So 5 times 0 minus 2. Y equals 0 minus 2. And so the y value is negative 2. So there I have my two values. Now if I take a look, I'm going to then take my x coordinate, my y coordinate, put them together as an ordered pair, and that would give me 0, negative 2. So my solution is 0, negative 2. So just a quick review. Remember, the equations need to be in slope-intercept form. If they are not, you rewrite them like I did here. Sometimes, like you saw on previous examples, like this one, the first equation was already in slope-intercept form. So make sure the equations are in slope-intercept form. Rewrite them if they are not. Once you do that, you will take the two equations and set them equal to each other, solving for the x value, which will be the x coordinate in your ordered pair. Then you'll take that x value and one of the two equations, whether it's the original two or the rewritten slope-intercept form equations, and substitute that x value into the equation to then find the y value for your ordered pair. Take the x value, the y value, put them together, and that will give you your solution for the systems of equations. Good luck.